Our story begins about 4.6 billion years ago. Imagine a vast swirling cloud of gas and dust. This is a nebula, a stellar nursery. Gravity, the architect of the universe, played a crucial role. As the nebula churned, it began to collapse in on itself. Gravity pulled the gas and dust particles closer together. The cloud became denser and hotter, particularly at its center. This central region, a crucible of intense heat and pressure, would eventually become our Sun. As the nebula continued to collapse, it began to spin faster and faster like a figure skater pulling in their arms. This marked the birth of our Sun, a brilliant star that would bathe our solar system in light and warmth for billions of years to come. With the Sun blazing at the center, the remaining gas and dust swirled around it, forming a vast protoplanetary disk. This disk, a cosmic carousel of matter, extended for millions of kilometers. The disk was not uniform. Close to the newborn Sun, it was scorching hot. Further out, temperatures were cooler. The inner region of the disk, bathed in the Sun's heat, was dominated by heavier elements like iron and rock. Further out, beyond a certain distance called the frost line, temperatures were cold enough for volatile compounds, such as water and methane, to exist as ices. Tiny grains of dust, remnants of the original nebula, started to collide and stick together. Over time, these dust bunnies grew larger, forming pebbles, then boulders, and eventually kilometer-sized objects called planetesimals. The protoplanetary disk, once a chaotic sea of gas and dust, was beginning to transform into a more ordered system. Within the disk, a chaotic dance of planetesimals ensued. These objects, ranging in size from small asteroids to dwarf planets, whizzed around the Sun, their paths intersecting and colliding. Most of these collisions were destructive, shattering the planetesimals back into smaller pieces. But some collisions were constructive, leading to the growth of even larger objects. In the inner solar system, where rocky materials dominated, planetesimals coalesced to form the terrestrial planets Mercury, Venus, Earth, and Mars. Further out, beyond the frost line, icy planetesimals accreted to form the cores of the gas giants, Jupiter, Saturn, Uranus, and Neptune. These massive planets, with their thick atmospheres and systems of rings and moons, are a testament to the abundance of material available in the outer solar system. It was within this tumultuous environment that our own planet, Earth, began to take shape. Section 4, the growing Earth, accretion, and the formation of proto-Earth. In the midst of this cosmic maelstrom, a particularly large planetesimal destined to become our Earth was growing. This proto-Earth continued to accrete material from its surroundings, its gravitational pull sweeping up smaller planetesimals and dust. As the proto-Earth grew, its gravitational pull intensified, attracting even more material and further accelerating its growth. This runaway growth resulted in a massive object, still extremely hot from the energy released during its formation. The proto-Earth was a hot, molten world, constantly bombarded by asteroids and comets. The heavier elements, such as iron and nickel, sank towards the center, forming the planet's core. Lighter elements like silicon and oxygen rose to the surface, forming the Earth's mantle and crust. The stage was set for the next dramatic chapter in Earth's story, the formation of the Moon. Section 5. A titanic clash, the Moon's violent birth. Around 4.5 billion years ago, a Mars-sized object, which scientists have named Theia, collided with the young Earth in a cataclysmic event. The energy released during this collision was unimaginable. Theia was completely obliterated, and a significant portion of Earth's mantle was vaporized and ejected into space. This debris, a mixture of molten rock and vaporized material from both Earth and Theia, formed a ring around our planet. Over time, this ring coalesced under its own gravity, eventually forming the Moon. The impact tilted Earth's axis, giving us our seasons, and it sped up Earth's rotation, shortening our days. The Moon, now tidally locked with Earth, stabilized our planet's wobble, creating a more stable environment for life to evolve. Section 6. A planet transformed, oceans, atmosphere, and the spark of life. Following the moon-forming impact, Earth was a very different place. The planet was incredibly hot, its surface a molten wasteland. Over time, however, Earth began to cool. The molten surface solidified, forming the first continents. Volcanoes erupted, spewing gases from the Earth's interior, creating a primitive atmosphere. This early atmosphere was composed mainly of nitrogen, carbon dioxide, and water vapor, with only trace amounts of oxygen. As Earth continued to cool, water vapor in the atmosphere condensed and fell as rain, forming the first oceans. These early oceans were likely acidic and hot, but they would eventually become the cradle of life. From a lifeless, molten planet, Earth had transformed into a world teeming with the potential for life.